Good morning, everyone. I think we have done with the Kubernetes cluster creation, and after that, what we have to do. So, on the Kubernetes cluster, the first way of installing your application on the Kubernetes cluster is nothing but pod. So, this is called a standalone pod. So we are not going to talk about containers. So in the Docker level, it is called as containers. So when we discussed about Docker engine, when you want to install some application on the Docker engine, we used to call them as containers. But when you have seen the Docker Compose, right? There we used to call it as service. Okay, if you remember the Docker Compose file, there we used to call it as service. So technically the name has changed, but ultimately the containers which we are trying to create. So if you correlate the technical terms into the Kubernetes level, now your containers are called as pods. Why it is called as pod? Pod doesn't have any abbreviation. It is just a pod. What pod has? What do you mean by pod? Let us try to understand first, and then we can see the practical session of it. Okay. So when someone asks you like what is a pod, you have to tell a simple statement that pod will ensure that containers with one or more are logically grouped together, which means that pod is just a logical layer. So how we have heard about LVM partitions and all, right? What is LVM? Logical volume manager. What it does, multiple physical hard disks will be grouped together and it will form a common layer. Okay, so similar to that, your pod also does the same thing. So technically it will group multiple containers together. It doesn't mean that always you need to have multiple containers. You can have a single container or multiple containers. It depends upon our requirement of the application. So this particular container which is running inside the pod or logically grouped together to have some particular functionality called common network and shared storage. So if you try to put it this as a definition, pod will ensure that containers with one or more are logically grouped together to have common network and shared storage. This is the main 2 points which you have to remember always when you're working with the pod. Okay, common network and shared storage. What does it mean for me? Okay, what does it mean for me to understand what is this common network and shared storage? Let's put this particular point aside, which is like high level, which I've told, but let us go deep into that particular common network and shared storage. So if you want to access your application, how will you access your application? A pod will be assigned an IP address. If you remember, when we executed kubeadm init command, we have passed a pod CIDR value, right? We have passed a pod CIDR value, and after that we have installed Calico, right? So in that the pod CIDR what you have specified, from that a IP address will be assigned to your pod whenever it got created. So you can see the statement over here. Pod will assigned with an IP address with the help of CNI, container network interface. Okay, it can be Calico, it can be WaveNet, it can be Flannel, but Flannel got deprecated, so you can put it this aside. WaveNet and AWS VPC or Azure VNI, whatever you use. The platform, based on the platform, it depends. Since we are using on-premises Kubernetes cluster, I'm using Calico for my networking. Why? Because if I use Calico, I can use better networking with a different CIDR values, and I have functionality like where I can apply pod network policies, and I can use BGP peering as well. So a lot of stuff I can do with Calico. Okay, with an open source itself. Okay, so that's the reason I've chosen Calico for my Kubernetes cluster, which we have deployed in our GCP instances. Okay, so I'll show you shortly. So this is what it is, right? So this is my Kubernetes cluster. If you execute kubectl get nodes, you can see I have two nodes. One is your controller and one is your compute, right? So this particular controller is having your all the controller related components of your Kubernetes cluster, and compute is having all the compute related components to run to form your Kubernetes cluster. So after this we have after this we have deployed our networking and all, which I've told you. Now how it looks technically. So what is this common network and shared storage? So common network, in the sense, technically when you create a pod, this pod can have one container or multiple containers. It could be possible, right? You can have one container or multiple containers. Okay, it looks like this. This pod which is having can be have one container or multiple containers. I'll come to that point. Okay, so if these two containers have two different responsibilities, okay, two different responsibilities. For example, let's say this container is trying to pull the data from somewhere, let's say from GitHub or somewhere it is trying to pull the data. That data will get stored into this volume. Okay, so this volume is used by both the containers. Okay, wherever it is storing, that's unnecessary for us, or we are not cared about it. But these two containers are using the same volume, which means that if I do some changes here, whether this container does the changes or manually you have done the changes or this container has done the changes, everybody will have the same data. Okay, whoever done the modifications, that will get reflected to all the containers who are using this particular volume. Okay, so that is called as shared storage. Shared storage in the sense, when you try to create a pod, if you use a concept called volume, you can have a shared storage. If this need to be done in your Docker Swarm or in your Docker standalone engines, right, it is really tough. I need to use some NFS, I need to configure that first, I need to mount that particular volume first, and then I have to use it to my container. So which is like you have to do so much of administrative task before your actual application is deployed. Okay, that's a headache which you have, right? And I don't want such a huge setup for my small data replication. Okay, so to avoid those kind of things, Kubernetes has providing you some particular concept called pod, which will logically group together to have a common volume, which is called a shared volume. Okay, that is the intention of using a pod, to have a shared storage. Okay, that is done. What about common network? So common network in the sense, both the containers in the pod will communicate with each other in the localhost IP address. Why? It doesn't, your pod is having IP address but not your containers. It is not assigned to your containers. Okay. Why? Because actually both the containers are created in a pod namespace, network namespace. I'm talking about only network, common network in the sense, both the containers or any containers which you try to create inside the pod, it will use the network namespace, pod network namespace. Okay, so which means that if you log into the container, any one of the container, both will show the same IP addresses. Okay, which means that there is some advantages, like both can communicate with each other which much faster because both are sitting on the same node and sitting on the same namespace. So communication will be much faster and easy to communicate with each other. The only thing that you have to consider while doing like this is nothing but you cannot install same applications which are listening on the same port number on these two inside the pod with two containers. You cannot create. If I want to create Nginx with listening on 80 port number and Apache web server which is listening on 80 port number, it is not possible. Why? Because one of the container will get created first based on the priority. Okay, like whoever takes priority, that will get created first. Okay, so once that got created, second container also it is trying to use the same port number which is already occupied by this container, which is not possible because both are running in the same namespace. A process which is listening on certain port number cannot listen on the same port number by another process. So that is what happens. So you have to consider this particular point, saying that two applications cannot listen on the same port number inside the pod. That is what you have to make a note. Apart from that, this is the advantage of using a common network. So common network in the sense, all the pods which are created inside the pod will have, all the containers in the pod will share the same namespace, network namespace. Okay, that's how it is. So this is the introduction to your pod, what it does exactly, what is the intention of using it. So let us take a simple example, and you have to remember pod can have a single container, pod can have multi-container, and then we have static pods as well. So we will understand the difference between these three later in the one by one. But first of all, let us try to create a pod with a single container. Okay, which means that the pod will have only one container. Later on, we will see how to create a pod with multi-container, which means that more than one container. Okay, so let's try to understand that. This is a simple YAML file. Okay, so this YAML file will be given by your user or a developer engineer, this YAML file. So once it is reached, to this particular Kubernetes cluster, the pod will get created. So this pod will download on whichever node it got assigned, either through the compute node 1 or compute node 2. The pod is assigned. For example, let's say it is assigned to this particular control plane 1. Okay, so once it is assigned to this particular node, uh, first it will download the image from the Docker Hub. If you are using Docker in the backend as a container runtime interface or containerd as a runtime interface, those will contact by default to the Docker Hub, and then it will download the images. Okay, it's up to you whether you pushed your custom images and all to the Docker Hub. It depends. But I given you this example as well. If developer has pushed the custom image to this particular Docker Hub, so pod will search for that particular image and it will download based on the parameter which you have passed. You can see here, I highlighted here. So the image will get downloaded, and after that the pod will get created. So in order to access this particular application, your container will be listening on 80 port number. And if you want to access this particular application from outside, right now we have in pod is nothing but host port, which is nothing but on whichever host this particular pod is running, on that particular node, a port number will be binded to your container. 8090 port number here in this example will get binded to the 80 port number inside the container. So this is how it does. So what does it mean? If I go to my GCP account, okay, let's say, okay, so this is my public IP address. Okay, once the container has been, the pod has been created, I can give, let's say it is assigned to this particular node. Since I have only one compute, obviously it will get assigned to this particular node. So I need to take this particular public IP and I need to go to the browser. I need to give HTTP IP address and the port number is 8090. So then I will be able to access my application. Okay, so let's see that. So here there are two ways to create your pod. Let me show you. Just a second, please. Yeah. So here there are two ways to create your pod. One is you will be writing a YAML file, and then that's how you will be launching your application inside the cluster. Another way is through CLI itself we can do it. Okay. So there are some, it is a bit hard to do from CLI. The better way is to write a YAML file in the production or whenever you work on any cluster. Okay. So right now we will see both the conditions. How to do it from CLI, which is called as imperative. This method is called as declarative. Declarative in the sense you are writing something in the file and that file will be used as an input to create the resource. That is called as orchestration. That's the reason your Kubernetes is called as orchestration tool technically. Okay. So let's see both the methods right now and how to create a pod. So you can take an examples from here. I have written some bunch of information about this particular pod, what is this pod and all networking, which I've told you right now theoretically. It talks about this storage, common storage, which I've told, shared storage, which I've told, right? Those points are written here. Okay, resources we can see later. It is not that hurry for us to understand about these resources inside the pod, how this will get allocated. Okay, so we can see later about this. But pod definition I have already written in this documentation, which I've already shared to you guys about that particular link, GitHub link as well. You can just read this particular documentation. So it is under Kubernetes. You can look for pods, okay, and then you can see open the README file. Okay, that's all. So now let us take a sample example. Okay, so you can see here I have written the flow as well here. You can just read this particular documentation. Okay, how to create through CLI and how to, which is called as imperative, and I given how to create through YAML file, which is called as declarative. Okay, so we can follow both the methods. So let me take this. Okay, so to take this particular example, and let's go to the terminal right now on the control plane. Yes. So now let's give that. Now what this command does, kubectl run, create a pod with this name and use this particular image. Restart policy always, in the sense for whatever reason this particular container is getting stopped, a pod is getting stopped, it will try to restart it. So let's say tomorrow I shut down, today I will shut down this particular cluster, for example, because to save my money in the GCP account. Okay, So when I apply this restart policy always, what does it mean? Tomorrow if I start my cluster, right, automatically this pod will come up. Okay, so that's a reason which will I will always give as always in this situation. Labels are nothing but additional metadata to identify or to filter your pods with this particular names. Okay, so these are just labels which are like metadata information to your pods, and this is the port number which will be opened in the container, which is like open in the sense it will listen on this particular port number which you already know. Nginx will listen on 80 port number, so that is what I'm specifying. Okay, and then I can give one more parameter called host port, which means that I want to bind this particular port number to my container's port number. So which means that I'm binding this particular port number to my container port number called 80. Okay, so here at the last I gave dry run is equal to client hyphen o YAML, in the sense it will show you how it looks, what it is trying to do on your cluster. It will not create actually, it will tell you how it looks. Okay, what it is trying to do. So what I have missed it, dry run, there is no gap here. Okay, there is no space. Okay, so now you can see it looks like this, right? This is getting deprecated in the coming feature. So right now we can use a host port, but we cannot in the later versions. So you can see here it looks like this: host port, container port. Port is nothing but your container port. Okay, which means that your container is listening on 80 port number. Okay, it doesn't mean that if I change a port number here, let's say if I mention as 8080, it doesn't mean that the application inside running inside the container will change. It will not listen on 8080 port number. It is, you have to customize. If you customize in your Docker file, then only you can change the port number. It doesn't mean that if you change a port number here, it will change the port number on which your application is listening. No, not at all. So don't get confused with this. We are just telling that my container will listen on this particular port number for our identification. Okay, and here we are binding this particular port number to this port number which we have specified here. Okay, now this will get created. If you remove this particular parameter, this will get created. If you add this particular options, it will show you what it is trying to do, what it will if it is getting created, how it looks. This is how it is. Okay, so let me remove these parameters and let me create it. Okay, so if I execute this command, now the pod has been created, right? So if you execute kubectl get pod hyphen o void, you can see now the pod is up and running. It is assigned to this particular compute node. Now I want to verify whether my application is working or not. So you can just give curl command and you can give your pod IP address. Okay, you can say welcome to Nginx, which means that this is working fine. Okay, so but this IP address you cannot give in the browser. It is a private IP address, and this IP address is restricted to be accessible only within the cluster. Either you can execute from control node or from compute node or any other node which is in the cluster. Okay, if you want to access from outside the cluster, since I did this particular host port binding, right? So what I can do, I can go to my dashboard, GCP, take this particular this. Oh, I already did this, right? Let me refresh. You can see now it's working, which means that say I got a response from my container. If you want the proof, let me modify that index.html. Okay, how will you log into your container inside the pod? So kubectl exec hyphen ti, t in the sense terminal, I in the sense interactive mode. In order to execute the command, I need to be in interactive mode. To execute, to create some particular terminal, we need a shell, right? So that terminal is getting created, will be open. Okay, so what is your pod name? Nginx, and I want to use bash shell. You can see I logged in. Okay, so now I want to update my index.html. So echo, let's say welcome to pod demo. Okay, so I'll just add a HTML page. Okay, like header h1. Okay, now I will update this particular detail saying user share nginx html index.html. Okay, what happened? Okay, just a small update. So go to the browser, and if I refresh this, oh, it is not updated. Okay, let me go. Oh, some mistake. Yeah. Okay. Let me go and refresh. You can see now. Welcome to pod demo. So which means that I'm getting a proper response from my pod, right? I was able to access from outside. How was this happened? If you remember, if you recall your Docker session, there I have shown you port forwarding, right? Which is nothing but port binding, which we also call it as port binding, in the sense what we used to use -p option, capital P or small p, whatever, it depends upon the situation. -p 8090, we used to give colon 80 port. So here it's nothing but it's similar to the option what we gave, 8090 port number binded to my 80 port number. Okay, so this is what we have done. So this is a simple introduction, like how to create a pod with a single container. That's it. Okay, so this is how. If you want to access your application from outside, since we don't know any other topic in Kubernetes, so this is the only option for you right now. If you want to access your application running inside the pod, if you want to access from outside the cluster, right now we have only this particular option. So think that in this way. Don't say that this is the final way we have to access your application. No, since we have not discussed any other topic, so that's the reason right now we have only this particular solution for us. Okay, no host port. Okay, so if you want to do it through YAML, so this is how we write. I've already saved here. Let me show you. It is written under pods, nginx. Yeah. So this is your API version. Okay, API version in the sense when you are executing some command to your first command or any command, or when you run some API call, your Kubernetes API, even when you execute it from CLI, okay, when you send a request, the first component who will take the request on your Kubernetes cluster is your API server, Kube API server. So it will verify what you are trying to create. Okay, I'm trying to create a pod that is mentioned in kind section. Kind in the sense what kind of object you are trying to create. It is pod. What is a pod API version? It will verify. Your automatically Kubernetes will validate the schema. So based on the API version. So if you want to verify this, you can just give kubectl API resources. Then you can give pipe grep pod. Okay, if you give this, you can look at this. What is the API version? It is V1. What is the shortcut name? PO. What is the full name? Pods. What is the kind? Capital POD. That is what I've shown you in the YAML file. True in the sense for every namespace it is different. It is a namespace specific. If you create this particular pod in one namespace, I can create the same pod in another namespace as well, because both are isolated. Okay, in the same namespace we cannot create two pods with the same name, but in another namespace I can create a same pod name in multiple namespaces. Okay, so do remember this point. Let's open this. Yeah, so this is what we have done. Name of the pod, spec, containers. If you want to create multiple containers, we will write one more session like this. Okay, name of the container, name, image, what you use, everything. Now we are creating only single container. So in this single container, we specified what is the name of the container, image, what image you are trying to use in order to create this container, what are the port numbers if you want to bind, or if you want to tell which port number is exposed, that is I mentioned in the name section. See, there will be multiple ports, right, which can be opened. So that's the reason it is like in the list format. Okay, so HTTP name of this particular section, container port is nothing but the port number which will be used by your container, that is 80 port number. 8090 port number is nothing but your port number which you are trying to bind on the node. Okay, so now if I want to create this, so kubectl create -f pod. Sometimes you might see apply, both are same. There is slight difference between apply and create. Okay, so we will discuss later about this, but right now you can use create when you're creating for the first time the resource. We can use create. Apply in the sense for creating for the first time, as well as if you want to update something on an existing resource. The resource is already exist, but I want to modify a few things, then we use apply. Okay, so create should be used only for the first time when you create. Apply for both creating for the first time, as well as if resource is already exist, if you want to reapply that, then it is apply. Okay, so nginx enter. Now this pod is created. Now this pod is called as nginx server, right? This is created through CLI, and this is created through what do you say, from the YAML. But now you can see, you can observe one thing, it is in pending state. How come? It should be assigned to this particular node, and the image is already there. It should not take less than one, it should take only few seconds to create, but it already crossed 7 seconds. And if I re-execute this command, I can see it is 29 seconds, still it is showing me in the pending state. What could be the reason? If you try to recap the things what we have done, if you recall, let me open that. Yeah, let's say this pod is assigned to this particular node. I have only one compute. Okay, now I'm trying to create, and I am using host port to bind this particular port number to this particular container. That is what I've done through CLI. Now I'm writing this YAML file to create another pod with a different name, and I'm trying to use the same host port. The reason is why it is in pending state. One container is already using this particular port number on the host, which is binded to that particular container. Now you are trying to use the same port number to be binded to this particular port number of the container, which is not possible. So that's the reason it is in pending state. Okay, that's the reason it is in pending state. If you try to give kubectl describe, okay, if you want to see that pod nginx-server, in the event logs, you can see that nodes are available. One node did not have free ports for the required pod ports. You understood? It is clearly telling you that you are trying to use 8090 port number, but it is not free on that particular node. That is what it is trying to say. So always execute describe command pod and see what it is having. In the event logs, you can understand why it went wrong. Okay, what went wrong while creating this particular pod. So now I understood, okay, this pod is already occupied with 8090 port number on this node. Since my cluster is trying to create the same pod on the same compute node, I was not able to use it. Why? Because 8090 is already in use. Now what I need to do, I need to change it, right? So nginx, instead of 8090, let's say 8091 for example. I know that it is not used. Now this is already there, I want to reapply this. So kubectl, let's say we can use apply or not. You can say it is not allowing us. So in the apply, only few parameters can be changed, but few parameters cannot be changed. Okay, in those cases what you have to do, you have to use a simple concept, is nothing but it should delete the pod and it should recreate. So replace --- force. This command will delete and it will replace with the new changes. Okay, that's how. Now the pod is created. Let's verify the status. Yeah, now we can see it is running. So one is running on 8080 port number and one is listening on 8091 port number. This is running on 8090. And if I try to reuse this with 8091, it will show me welcome to Nginx. Okay, so these two are from two different pods. Okay, so this is how we have to understand, like when you are using certain concepts, certain options, they will have some limitations. The best example is this host port. The limitation is when the port is already occupied on that particular node, you cannot reuse the same port number to be assigned to another node. Why? Because kubeproxy will update the IP tables. Your kubeproxy component is there, right, which we have discussed in the architecture. Every node will have kubelet and kubeproxy. Kubelet will ensure that the pods are getting created. Kubeproxy will ensure that the network proxy is done. Network related proxies or everything are done on the nodes. So this is nothing but a network proxy, which means that from outside we are trying to access this particular port number on the node. Kubeproxy on that particular node will know how to divert this particular traffic to that particular port number on which the container is listening. So that is what the job of kubeproxy does. Okay. more other things as well, but here I just want to tell you about kubeproxy example, how it will come into picture in this scenario. Okay, so this is about your introduction to your pod and a single container pod. Okay, so to create multi containers, to understand what is a common network and shared storage, we will see in the later session. Okay, in the next session we will say how to create multi containers, which means that in a single pod I will try to create multi containers. There I will show you what is common network, what are the disadvantages we have, means like what are the limitations we have, not disadvantage, what are the limitations we have, and what is a shared storage, how to utilize that. Okay, so in the coming session we will see that. Okay, thank you.